right, so this is a review of Chapter 11, the topics that we took on Quiz 1. What you should do right now is pause the video, try to do every problem, and then watch the video to check your answers. And if there's any answers that you got wrong, you should specifically watch that part of the video more closely. All right, so looking at number 1, f of x equals 2/5 x plus 3. They're asking us to find f of negative 5. What we should note is that this negative 5 is in the parentheses, which is where the x was to begin with. So that tells me that really x equals negative 5, and I should be putting negative 5 everywhere I see the x. So f of, instead of x, we'll put negative 5 is equal to 2/5. Instead of x, we put negative 5 plus 3. So we're going to combine that to get a new exponent of negative 2. So it's 2/5 to the negative 2 power. Now, I would distribute that to each piece in here. So that'd be 2 to the negative 2, 5 to the negative 2. But remember, we're not allowed to have negative exponents. So in order to get rid of the negative exponent, we move it to the other part of the fraction, making this. So we're going to move the 2 to the bottom, making it 2 squared on the bottom, move the 5 to the top, making it 5 squared on top. And now we can actually do that exponent. So 5 squared is 25, 2 squared is 4. So 25 over 4 should be your final answer. All right. Number 2 asks you to evaluate this. So since they're only giving us this in log form, it's not an equation, so we're not trying to solve for a variable. That means we really have to change this into exponential so we know what's going on. So this is really saying half to some power should equal 1/8, right? So half to some power that we don't know what it is equal to 1/8. Well, normally we would try to change these bases to be the same. And I would really think about this as, well, right now the numerators are the same, so how do I get my 2 to become an 8? In other words, 2 to what power would give me 8? Well, 2 times 2 is 4, times 2 is 8, so that would really be a 3. So 3 is your final answer for number 2. All right, number 3. This one's asking us to solve it, right? So again, as soon as I notice that there's a variable inside of the log, if I'm going to solve it, I need to get the variable outside of the log. So to get it outside of the log, we need to change it to the exponential format. So remember, if there's no base here, the real base is 10. I'm going to zoom in on that to make that easier to see. So since there's no base on that one, the real base is 10. So this is 10 to the second power equals x. So 10 squared is 100 equals x. So 100 is our final answer. All right, number 4. Evaluate. Now this one is specific because it says to round. The reason why it does that is I could try and do this on my own, right? Really, it'd be 0.3 to some power is equal to 4.2. But I can't figure that out because it's a decimal, and really, even if I got rid of the decimals, 3 to some power equaling 42, I have no clue what that would be. So, because we can't do it this way, we're going to have to use the change of base. So we can type it in our calculator, which is why it's telling you where to round to. Okay, so we would change this to be log of the thing in the parentheses over log of the base, which was 0.3. And then we can go ahead and get our calculator out and go ahead and just type now. Log of 4. Oops, there's already a parenthesis there. Make sure you end your parenthesis before you do the division to start out your new log. And we get negative 1.191957. So your answer, because it says round to 4, 1, 2, 3, 4. Well, this 5 would make my 9 become a 10, which really makes that a 2. So it would be negative 1.1920 as our final answer. Okay, all right, so let's look at number 5 then. again, in number 5 here, we're asked to solve this, right? But as soon as I see that I'm solving and there's a variable in my exponent, I can't solve it if there's a variable in my exponent unless I can make the bases the same. Well, e is that number, right? That 2.1 number, 2.718. There's no way for me to make a decimal have the same base as a 6. So that means I cannot just make the bases the same in order to solve. So instead, in order to get the exponent out of there, I'm going to change it into the log format, right? So log of the base, which in this case the base is e, equals, log base e of the answer equals the exponent. Now you have to remember, as soon as you see log base e, that's really the natural log of 6 equals x plus 2, right? And then we can go ahead and we can subtract 2 from both sides to get x equals ln of 6 minus 2. Now if they ask for an exact answer, this would be your exact answer. However, if it's not specified, then you should type in your calculator and round. So ln of 6 minus 2, making sure that you close your parenthesis, is equal to negative 2.08. So x equals negative 0.208. All right. The next one isn't asking us to solve at all, right? It's asking us to condense. In other words, we need to put this into one thing. So since there's subtraction between them, that means it's going to be division. So this is really ln of x squared minus 4x minus 12 over x plus 2. Now if I'm going to actually get to my most condensed version, I have to simplify this fraction, which means I need to factor it. So if I look at the top, there is no GCF. Since my first term is 1, I can think about what multiplies to my last, which is negative 12, and adds to negative 4. So that would be 6 and 2. So x, 6, x, and 2. To get a negative 4, I would need my 6 to be negative, so then my 2 would be positive. On the denominator side, there is no exponent of 2, and there is no GCF, so it just stays x plus 2. And this is all with the natural log. And now, because we have the same factor on the top and on the bottom, these will cancel out, leaving me with simply ln of x minus 6. So make sure whenever you're doing these condensing problems that once you put them together, you try to simplify it even further. All right, number 7. This one is asking us to solve. Well, my issue right now with solving is that there's a lot of logs here. So if I'm going to solve this, I need to condense down to get just one log on each side. So let's just focus on the left. Since there's addition between them, that means we're going to be multiplying. So we're really taking x and we're multiplying it by x minus 1. And all of that is in log base 3. So then we can go ahead and distribute, and we get log base 3 of x squared minus x on the one side. On the other side, again, it's addition between, which means we're going to multiply. So we're going to do x minus 4 times x plus 2, and all of that is in log base 3. And so we have to distribute this out to get x squared plus 2x minus 4x minus 8. So we can combine our like terms, and we end up with log base 3 of x squared minus 2x minus 8 equals log base 3 of x squared minus x on the other side. Now again, we should note that these are the same logs, right? Logs with the same base. If we have logs with the same base, then the insides have to be equal in order for the two sides to be equivalent. So now I can just say x squared minus x equals x squared minus 2x minus 8. Now we need to go ahead and solve this. In order to solve this, we should probably get all of our x's together. So I'm going to move my x squared first. by subtracting, and the x squareds actually end up canceling, leaving me with negative x equals negative 2x minus 8. So now I only have x terms. I don't have any x squareds, which means I don't have to worry about factoring. So I can go ahead and get my x's together by adding 2x. So we end up with x equals negative 8. Now again, we should check this to see if it works. And since this makes this one negative here, that means there's actually no solution at all, because even though negative 8 appears like it should be the solution, negative 8 actually cannot work because we need to check for extraneous solutions. And that one's an extraneous solution. So even though we got an answer in the end, that answer doesn't work, so it is no solutions. Okay, let's look at example number 8. Okay, so looking at number 8, my issue here is we've got exponents on both sides. If we've got exponents on both sides that have variables in them, we cannot just change this to log format because there's too many exponents here. So as soon as I see that there's exponents on both sides, I know that I'm going to have to make my bases the same. If I can make my bases the same, then we can set the exponents equal. So I have an 8 here and a 32 here. So the first thing I check is, does 8 to any power give me 32? Well, 8 squared is 64, so definitely not. So I have to think about, what can I make these? What number that's lower than 8 can I make those so that the bases would be the same? Well, I know 2 to the third power is 8. Does 2 to some power give me 32? It does. So I'm going to make my base 2. So 2 to the third power gets me to the 8, right? And then we still have negative x minus 4 as our exponent. Then when I look at the other one, I'm going to use 2 again, but look, my number's in the denominator, so I know my exponent's going to have to be negative to move it to the denominator. And then 2 to what power is 32? So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, which means this one has to be a negative 5, and we still have the exponent of 3x on the outside. Now remember, whenever we have an exponent to an exponent, that means that we multiply them, right? So this is really 2 to the 3 times negative x minus 4 equals 2 to the negative 5 times 3x. So now that my bases are the same, I can set my exponents equal, because if these are going to be equivalent, the exponents would have to be equal as well. So on this side, when I distribute, I get negative 3x negative 3x minus 12 equals negative 15x. Then I'm going to add my 3x to both sides. So we get negative 12 equals negative 12x. And when we divide by negative 12, we get x equals 1. And then remember, this is one of those that we can go back and check in our calculator. So I can go ahead and type it in and say, okay, 8 to the negative, and now instead of x, we're going to put a 1, minus 4, and see what number we end up with. And then I'm going to do the same thing over here. So 1 over 32 to the 3 times 1. And these are the same, telling me that yes, that's equivalent. So yes, my answer is 1. So don't forget, on quizzes and tests, you can check your answers on those problems to make sure that you are accurate. All right, so let's look at number 9. Number 9 asks us to solve this. Now again, when I look at this, there are only exponents on one and not on the other one. That tells me that I don't have to make the bases the same. And I know I can't make the bases the same because e is the base on this one, which means we're going to have to change it into logarithmic form to get the exponent, the variable, out of the exponent. So log of the base, which in this case is e, log base e of the answer equals the exponent. And anytime I see log base e, I should automatically change it to the natural log. Okay, now we can go ahead and solve this by subtracting 3. So x equals ln of 6 minus 3. That's my exact answer. And then I can go to my calculator to go ahead and get my estimate. So ln of 6 minus 3 is negative 1.208. Depending on the problem, either would be acceptable, but make sure you follow the instructions to determine if you need the exact answer or the estimate. And we'll continue this on the next video.